Okay, so today's discussion centers on finding the largest domain algebraically. And we're not going to deal with pictures like we did the other day or so ago. We're going to try and figure out the domain from just looking at an equation. What comes to mind when I say the word domain? Yeah, the x-coordinates or the x-values. So when you're asked to find the domain of an equation, you're really asked to find all the possible things that you could sub in for x. So if you look at this equation right here that we've written down, number 1, is there anything that you can't sub in for x? In other words, is there anything that would make that equation undefined? Yes or no? No. If you don't think that anything makes the equation undefined, then the domain of this particular equation is said to be all reals. Another way of writing that is negative infinity to infinity. Now you can take a look at equations using your calculator just by plugging it in. So turn on your calculator, clear out any y values that have been entered in. Take the equation that's given to you and just plug it in. Hit the graph button, and you can create a quick sketch of what it would look like. This is a line. It goes off to infinity in both directions for the domain. And so it's as we said, all reals will count. Okay, so here's our new equation, y equals the square root of x. Is there anything, we're trying to find the domain of this equation. Is there anything that you can't enter into that? Is there anything that makes it undefined? And if so, why? So we're trying to think of numbers that can't be entered into this equation for x. Numbers that if you used your calculator and plugged them in, the calculator would report back an error message. And so let's test out one possible solution. What's a possible number that we could enter that can't be entered in there? -3. Let's see. Can you take the square root of -3? No, it's not a real answer. So that's good. That's good. That's good. What about some other suggestions were 0? Nope, that one works. That one works. Okay. What's up? Oh, the problem with that is that would be the whole numbers. Could you sub fractions into this? Perfect. Yes, that is the domain. In fact, for this guy, the domain is all values greater than or equal to 0. So x has got to be greater than or equal to 0. Another way that you could write that down is that 0 is the lower bound, and it goes all the way up into infinity. And we're going to put an or up over here because they both mean the same thing. So one or the other. All right, so we're going to step our game up a notch and try and figure out, so right now we have a fraction. Let's take a moment and think about it. What can't x be and why? Problem. Okay. So we just had a discussion. Take a look at the denominator, right? The only thing, whenever you have a fraction, denominator can never be equal to 0. But will any other number for x work? Perfect. So now when we try and talk about the domain, how are we going to write that down? Well, yeah, we could do that. We got to say something else though. Not the so it can equal 0, but then we have to give a description for everything else it could possibly be. Go. Say. Or less than 0. You could do it that way too. You could do it that way too. We're going to do it. Let's take down some notes, some possible ways. I'm sorry, of writing this down. All reals, comma, x just can't be equal to 0. You could just write it this way. Now, the other way, or we could write soft bracket negative infinity to infinity. X can't be equal to 0. That's what I did. We've also had a suggestion to say, let's take a look at the graph of this. We're going to enter it in 1 divided by x, and we're going to look at what the graph looks like. It looks like some crazy thing like this. Yeah, that's a hyperbola. That's a hyperbola. And we're going to go into the table of values as suggested. And you see that there's an error message at 0. Yep, because that is the asymptote. And by definition, really, that's what that's what an asymptote is for the x direction. It's something that it can never be. All right, so we got a fraction now, and we have a radical in the denominator. And here's the structure for solving really hard problems. What we do is we're going to take notes on it. First of all, we know that the denominator can't be equal to 0. Okay. And then we also know that because of square root, right, x has to be greater than or equal to 0, right? So how do we combine both of these into one domain, right? It can't be 0. X has got to be greater than or equal to 0. The only solution to this is the fact that the domain must be that x has to be greater than 0. Okay? And if you wanted to represent that using set notation, you would use a soft bracket on 0 all the way off into infinity. To address this scientifically. You say to yourself, okay, so I got a fraction. Well, what do I know about a fraction? The denominator can equal 0. Yep, we know that. So then here's the weird thing we're going to do. We are actually going to set the denominator equal to 0 so that we can figure out what values for x we cannot plug into the equation. And so we factor. This is x plus 3 and x minus 3. We solve. Plus 3 to both sides. I should have a little equal sign. So x equals 3. X equals negative 3. And so those are the two values. These guys right here are the two values that will make the denominator equal to 0. So weirdly enough, now when we write our domain, what's the domain of this? Yeah, the domain is all reals, comma, x cannot equal negative 3 or 3. Another way that you could have written this or seen it is that everything from negative infinity to infinity will work, except that x cannot equal negative 3 or 3. You also could have written this out in words as someone has suggested, that x can equal all real numbers, except that x cannot equal negative 3 or 3. If you wrote that as a sentence, that would also be okay as well. All right, new problem. New problem. Yep. We're going to factor this, right? Denominator can't be equal to 0. By the way, somebody in the other class asked, do they need to continuously write this stuff down? I do it because it helps organize information. Tomorrow when we do the really hard problems, you'll see that they're not so hard when you keep everything in your mind written down on the paper. Denominator can equal to 0. So here we go. We got x squared plus 8x plus 12 equals 0. We're going to try and find the values. We're going to factor that real quickly. That's x plus 6, and that's x plus 2. Right? I'm going to solve it really quickly, as some people will do on their paper. Right? X equals negative 6 and x equals negative 2. And so therefore, guys, what's the domain? Yeah, it's all reals, comma, x cannot equal -6 or -2. Perfect. Oh, we're doing good work today. Yeah. So we got a new problem. It looks ridiculously complicated. Angela, can you tell me what's going on? We got something in the top. Does it matter at all what's in the top? Why? The, yeah, the top can be anything it wants. In fact, any of you guys taking the SATs, so on some of the questions they throw in extra stuff. The top is called a distractor. Okay? All we're going to do is, I'm dead serious. We're going to just take a look at the bottom. All you need to know is that the denominator cannot be equal to 0. Can't equal 0. So we set it equal to 0 and we solve it. And we did this before, so I'm going to go really fast through it. You know, and then we found that x is equal to 3 and -3. And so what's the final answer to our problem? Yeah. This is just the introduction to it. Oh man, you know, you guys are like the other class. They go, just show us the hard problems. Let's just do all the hard problems right now. No, no, what about this? What about this? Let me write the homework up on the board and then I'll show you the hard problems, okay? Okay, I'll show you what you're in for tomorrow. Homework. Oh, here's what I want you to do. You got 3 problems to do. Find the largest domain. Find the largest domain. And I know they're really easy because I want you guys to be real comfortable with this. Y equals 3x plus 4. I know, it looks just like something we did today. Then you got y equals 5x plus 1 over x squared minus 49. Right? And then problem number 3. Problem number 3, I want you to do y equals 1 over the square root of x. If you run into trouble, do me a favor. Look through your notes.